welcome to today's tutorial. So in this tutorial we're going to discuss a simple question that you are seeing on the screen right now. Okay, so the question says find the relative extrema of the following function: f of x is equal to 2x over x squared plus 1, defined on a closed interval -2, 2, closed and open and closed. Okay, so first of all, let me say, if you have not yet subscribed to my channel, make sure that you do so by clicking on the subscription button. And then if you have any questions or you want to join my tuition group, you can simply just text me on any of these lines on the screen. And then don't forget to click on the notification button so that whatever video that I post, you get notified. In short, you not miss out any video that I will be posting. Alright, so make sure that you do the following: you subscribe and also click on the notification button. Alright, so let's quickly move on to solving the question. Okay, so the question says find the relative extrema of the function f of x is equal to that. So when we talk about the relative extrema, we're simply talking about the minimum and the maximum points within this given interval. So the interval that has been given is from -2 to 2. Okay, so now to find these extremas, we first find the first derivative. So finding the first derivative, okay, let me first copy the equation. So we have f of x is equal to 2x over x squared plus 1. So we're going to first find the first derivative of this function. So when you look at this function is a rational function, meaning it's a fraction. So we use what is known as the quotient rule. Why? Because we have two functions dividing. So we're going to use the quotient rule to find the first derivative of this function. So how do we apply the quotient rule? So we're going to equate what is on top to u and what is down to v. In case you don't know why I'm doing that, we know to say the quotient rule is used to differentiate functions that are in the format u over v. And then the quotient rule also states that y prime, or if you have f of x here, you can say f of x prime. So y prime is equal to v u prime minus u v prime. So if we say prime, we simply just mean the derivative of that given function. So you find the derivative of u and also the derivative of v, and then you put them there respectively. And then you say over v squared. Okay, so this is the formula that we're going to use to find the derivative of this function. So my u is just equal to 2x, then v is equal to the denominator there, which is just this part, which is x squared plus 1. So we find u prime. U prime is simply just equal to 2. When you differentiate this, you just get 2. Then v prime will simply just be 2x. So now we plug them into this equation to find f prime of x. So the reason why we're finding the first derivative, we know that the first derivative is known as the gradient function, and at these extremas, or at the minimum or the maximum, we know to say the first derivative is equal to 0. We know that the gradient is equal to 0. That's why we equate it to 0. So after finding the derivative of this function, we're going to equate it to 0 to find the critical points. And we're going to use these critical points to determine the extremas. Okay, so f prime of x will now be equal to, so we put our v is x squared plus 1, and then we also have u prime is simply just 2. When you say minus, u is equal to 2x and then v prime is simply just this part, which is 2x as well. So we divide everything by v squared. So my v is x squared plus 1, so I'm squaring this. So now let's simplify this expression. So simplifying the expression, we're going to have 2 times 2x squared, 2 times x squared, we're getting 2x squared, then plus 2 times 1, we're getting 2, then minus 2x times 2x, we're getting 4x squared. Okay, so this is what we're going to get as so this is what we're going to get as the expression on the numerator, and then the denominator will still remain as x squared plus 1 then squared. So 2x minus 4x squared, we're going to get negative 2x squared. So f prime of x is now going to be equal to, so we'll have 2 minus 2x squared and everything divided by x squared plus 1 squared. So this is our first derivative. This is our first derivative. And the other thing that we need to know, remember what I said is, since this is also known as the gradient function, at the minimum or the maximum, the gradient is equal to 0. So what we're going to do now is we are going to equate this gradient function to 0 so that we can find the critical points. So we have 2 minus 2x, then everything divided by x squared plus 1 squared. We equate this to 0. So when you cross multiply, you just remain with 2 minus 2x. Yeah, you're just going to remain with 2 minus 2x. I'm sure this is supposed to be x squared. Yeah. So we have 2 minus 2x squared is equal to 0. So you take this other 2 to the other side of the equal sign so that you get negative 2x squared is equal to negative 2. So when you divide everything by negative 2, you get x squared is equal to 1. Meaning when you find the square root of both sides, you're going to get x is equal to plus or minus the root of 1, which gives you x to be plus or minus 1. So we have two values of x, which is x is equal to 1, x is equal to negative 1, and the other x value is equal to positive 1. So these are known as the critical points. So these are the critical points. And then the question is asking us to find the relative extrema in this given closed interval. So what I'm going to do is I'm going to write a simple data table, a simple table here. So this side I'm going to put the values of x, then this side I'll put the values of f of x, which is just the same as the values of y. Okay, so this side we have negative 2 as the highest value that we want to test. Then we also have negative 1 there. We also have 1, which is this one, positive 1, then also positive 2. So we're just going to restrict ourselves in this given interval. So if it was open for every number, we would have just gotten these numbers and then plug them into this expression, then find the maximum and the minimum. But in this case, we've been given the interval, so we make sure that the numbers that we're putting this side are within the range or are within the interval that we've been given. Alright, so let's quickly plug in negative 2. So if you put negative 2 where there's 2 there, you're going to get, so if you put negative 2 where there's x there, you're going to get negative 4 on top. You're going to get negative 4 on top, and then the denominator will be 2 squared plus 1, which is 5. So this will be negative 4 over 5. So if you put negative 2, you're getting negative 4 over 5. So when we put negative 1, put negative 1 there, you're going to get negative 2 on top, everything over when you put negative 1 down there, this will be 1 plus 1, so negative 2 over 2. So negative 2 over 2, which is just going to give us negative 1. And then we also have 1 here, so when you put 1 there, you get the same number, it to just be positive, because when you put 1 there, you get 2 over 2, which will give you positive 1. And then when you put 2 while there's x there, you're going to get 4 on top. And then when you put 2 while there's x down there, you get 2 squared, which is 4, plus 1, which is 5. Alright, so here it's just a matter of getting the highest value and the lowest value, and the two numbers that you are going to get are the ones that you are going to take as your relative extremas. I mean, are the ones that you are going to call your relative maximum and relative minimum. Okay, so let us check. So this one is just the same as what? Negative 0.8. So that 4 over 5 is just the same as negative 0.8. And then we have negative 1. So this one is negative 1. Then we also have this one, which is positive 1. Then this one is 0.8. So here is just a matter of getting the highest and the lowest value. So as we can see, the lowest value is negative 1. Yeah, the lowest value is negative 1. And then the highest value here is 1. So meaning the relative maximum, yeah, so the relative maximum is so the maximum is simply just equal to 1, and then the minimum is simply just equal to negative 1. So these are the relative extrema which they want us to find. Alright, so this is exactly how you do how you solve these questions, these types of questions. Then the other thing I forgot to explain, you also have to check if you also have a critical point on the denominator here. Yeah, you can also check that, or and then how do you check that? You simply just equate this denominator to 0. So when you equate that to 0, you discover that x squared plus 1 is equal to 0. So the reason why I didn't do this, because I already knew that if I equate this to 0 to find x, I'm going to get x squared is equal to negative 1. The square root of a negative number is an imaginary number. So this one, we can say there is no critical point which exists on the denominator. And then apart from that, you can also check the points at which the derivative does not exist. How do you check that? It's by equating the denominator of the derivative to 0. Yeah, so that will also help you to find other critical points. But otherwise, this is how you solve such a question, this kind of a question. So thank you very much for watching today's tutorial. Make sure that you subscribe to the channel if you have not yet subscribed to the channel. And also, don't forget to click on the notification button so that you don't miss out the videos that I'll be posting. If you have any questions or you want to join tuitions that I'm offering online, feel free to contact me on any of these lines on the screen. Yeah, so my name is 𝑒𝑥𝑡𝑟𝑒𝑚𝑎. See you in the next tutorial video. Shalom, shalom.